Today we're going to talk about triangle similarity with right triangles. And for some reason, this tends to trip kids up. So all of its parts make total sense, but just when you put it together, some kids have trouble making that leap. So stay with me, and we can go over questions tomorrow. But all right, so the triangle similarity theorem says that if you draw an altitude to the hypotenuse of a right triangle, it creates three similar triangles. So if I'm drawing my altitude, it creates three similar triangles, and they're all right triangles. So it creates this triangle, this little one, it's like the baby bear triangle, the medium-sized mama bear triangle, and then the large papa bear triangle. All right, so let's talk about the similarity of these triangles. We drew an altitude from the top of the right angle straight down to the hypotenuse, and it created three triangles, a baby triangle, and let's label those sides, or those angles, it's Z, Y, and X, right? We had a mama bear triangle, which we're going to label W, Z, and X. And then the papa bear triangle, which is everything, W, X, and Y. All right, and then we're going to write a similarity statement. So the first triangle, the baby bear triangle, let's start with the right triangle, Z, and then go down the short side to Y, and then along the hypotenuse to X. Okay? So let's do the mama bear triangle now. We're going to start at the right angle, Z, travel up the short side again to X, and then along the hypotenuse to W. And the papa bear triangle starts at the right triangle, X, then we travel down the short side to Y, and then across the hypotenuse to W. Okay, and there's my similarity statement. Okay, all three triangles are similar. Means their sides have the same ratio, angles are equal. Okay, now the second part, kind of separate, is the geometric mean. So let me just tell you math-wise what that means. And you know what an arithmetic mean is. Like if I ask you to find the arithmetic mean of 90 and 80, you'd add them up and divide by 2, right? And you'd get 85. That's arithmetic mean. Geometric mean is when to find the geometric mean, you take the product of two numbers and their square root. So the geometric mean of 2 and 8 would be the square root of 2 times 8, or the square root of 16. So the geometric mean of 2 and 8 is 4. Okay? Because when an arithmetic sequence goes up by the same amount, so it really is like halfway between 9 and 8. But geometric means go up by a scale factor, so the middle between 2 and 8 is not this, in a geometric mean, is not the actual middle between the two numbers. It's the middle for when you're thinking about growth at more than one at a time. So if that doesn't make sense, the best way to do it is just remember, the geometric mean is when you multiply the two numbers and take the square root. So the geometric mean of 10 and 30 would be the square root of 10 times 30, which would be the square root of 300, which is, 10 square root of 3. That's the geometric mean of 10 and 30. All right? Now, putting these two concepts together, this is where people have trouble. Um, you can find the lengths of these similar triangles we were just talking about, the baby bear, mama bear, and papa bear triangles, because they're related geometrically. Okay, because remember, in similarity we use ratios, and in geometric mean, those are also growing. Instead of growing by ones and twos, they're growing by a factor, like a fraction or a multiple of some number. Okay, so we just have to remember that. All right, so here is the 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 verbiage that explains it. So you can read over that, and if that helps, you can use that. They do something kind of weird. Instead of using the square root, they squared both sides. So the way I think of it is h is equal to the square root of xy, and b is equal to the square root of yc. I think they just want to avoid the square root symbol. Um, but for me, it's kind of easier to think that the length, this length, h, okay, so it's the altitude that we drew to create those three triangles. This length, h, the length of it is equal to the geometric mean of the two pieces of the hypotenuse that it created. So it's this x and this y. So the length h is equal to the geometric mean of xy, which geometric mean, remember, is the square root of the product of x and y. Same thing with the legs. This leg is equal to, the length of this leg is the geometric mean of the piece of the hypotenuse that touches it and the whole hypotenuse. So in this case, it would be y at times c, geometric mean of y and c. For a, since a over here is touching x, the length of a is the geometric mean of x and c. So b is y and c, a is x and c. All right? Just another way of finding pieces of a right triangle. Just another handy, there's just so many tools that are available to us with right triangles. So take a second and see if you can find u, v, and w. Okay, so the u here is equal to this length here, 9, is equal to the geometric mean of the two pieces of the hypotenuse that make it up, or that it creates. So 9 is equal to the geometric mean of u and 3. So 9 is equal to the square root of u times 3. Then to solve that, I square both sides, so I get 81 is equal to 3u, divide by 3, and I get 27 is equal to u. So u is 27, which makes the rest of it really easy because all I have to do then is plug in to find v and w. So v, this side here, is the length of that side is the geometric mean of this piece of the hypotenuse and the whole hypotenuse. So it's 3 times 30, because 27 plus 3 is 30, okay? Which reduces down to 3 squared root of 10. And w is equal to this length over here is equal to the geometric mean of 27 and 30, because it's the whole, it's the part that touches it and the whole thing. And that reduces down to 9 squared root of 10. All right? So if you want some more practice, go ahead and do this one. I'll show you the answers second. Okay, and just to point out, like, you can just solve it any way you want. You can do it the long way, but remember that y is 4 times the square root of 13. So when you get square root of 52, you break it down into 4 and 13, which is 2 square root of 13. But you knew that at the beginning, so you knew that you're going to pull the 2 out and leave the 13 in. Same thing here. You know you're going to pull the 3 out here, and and leave 13, so it's 3 squared root of 13. But if you want to go ahead and multiply it and factor it out, that's also great. Okay? All right. So that's it. We'll do this tomorrow.